All right, so we have our last lesson for the chapter 7.7. We're going to multiply polynomials. So in your table of contents, there's your date, and we will get started. So when you multiply polynomials, you might be distributing, you might just be multiplying straight across. This example looks kind of complicated and a lot going on, but what we want to notice is we actually have three monomials that we're multiplying, and you have your three sets of parentheses. So we did a little bit of this when we were learning how to use our multiplication properties with exponents. On this example, what you want to do is multiply the pieces that go together. So for example, you have a 15 out in front of the xy squared. You can go ahead and multiply that with the 1/3 of that monomial. 15 times 1/3, if you think about it as 15 over 1, multiply straight across, you get 15 over 3 or 5. So our answer is going to have a 5 in it. Now what you're going to do is multiply all the like variables. So you have an x to the first power. I'm just going to write this over here so I can keep track of it. This I know you can do in your head though. You have an x times an x squared. And then you don't have any x's in the last one. So x times x squared. When you guys multiply the same base, that's x to the first power, you add those exponents. So it's going to be x cubed. So I have a 5x cubed. Now I'm going to look to multiply any y's. I've got a y squared. So y squared times, in the second polynomial, I don't see any y's, but I see one in that last polynomial. So y squared times y to the third power, add your exponents, you get y to the fifth. And now I look for any z's. I do see we have a z cubed times a z to the fourth. So z cubed times z to the fourth. Add your exponents and you're going to get z to the seventh power. So I just kind of did off that work off on the side. You do not need to do that, but I just want to show you what we were actually multiplying. It got kind of crowded in the middle of that example. So multiply your coefficients, multiply your like variables. Because those variables have exponents, we are adding exponents for this to happen, and we get our answer. All right, so now we have a monomial, one term, out in front of a set of parentheses that has two terms inside. So you have a monomial times a binomial. This is just pretty much distribution. So you're going to distribute, and when you distribute, you're just going to go through and multiply the like pieces. So multiply your coefficients. -2 times 5 first. -2 times 5 is a -10. Then you can multiply the x's. You have x cubed times x to the fourth. Because you're multiplying two of the same base, you keep your base of x and add your exponents. You're going to get x to the seventh. Next you multiply your y's. This one has a y, but there's no y over here, so that y is just going to stay the same. And then we multiply our z's. You have z squared times a z to the first power. When you add those exponents, you're going to get z cubed. So that's the first term of our answer. Now you have to distribute to the second term. So start with your coefficients. You have a -2 times a -6. That negative times negative will become a +12. Multiply your x's. X cubed times x to the first. Adding those exponents, you're going to get x to the fourth power. Now multiply your y's. You have y times y. Adding your exponents, you get y squared. And then z squared times z to the fourth. Keep your z, add the exponents, and get z to the sixth. So that looks kind of weird, but that's our answer, so we're good. All right, when you get to binomials times binomials, we do this thing called FOIL. I'm not sure if you guys have seen FOIL before. So FOIL actually stands for something. The F stands for first. I don't usually like to write it this way, I don't know why I am. The O stands for outside. The I stands for inside, and the L stands for last. Sorry, I just did that vertically. All right, so when you multiply the first terms, you're saying the first term of each binomial, so that's x times x. X times x is x squared. Because we just multiplied, we added our exponents. Now the outside terms mean take the outside of your two binomials, x times negative 10 is a negative 10x. Now you multiply your two inside terms. 2 times x is 2x. And you multiply the last term of the first binomial times the last term of the second binomial. You get a negative 20. So with foiling, oftentimes you want to take a look to see if those two middle terms will be able to be combined, and in this case they will. You have x squared, a negative 10x plus 2x. Now that I'm adding these together, all you do is add or subtract the coefficients, and your exponents will not change. You only change your exponents with multiplication, and that minus 20 comes down. All right, this next one, it's going to be really, really tempting to say, hey, let me take that 2 and bring it into everything on the inside. We had an exponent property that let us do that. The problem with that is this 3x plus 1, do you guys see this plus sign? Because there's a plus sign, so if you have any addition or subtraction inside your parentheses, you cannot bring your exponent in like we can on all the other problems. What you want to do here is just say, well, if you have 3x plus 1 and you're squaring it, what does that actually mean? That means you're taking 3x plus 1 and you're multiplying it by itself. Once it's written out, now you can FOIL the problem and get your answer. So first term times first terms, 3x times 3x, multiply your 3's to get 9, multiply your x's to get x squared. Now the outside terms, 3x times 1 is a positive 3x. Multiply your inside terms, you get a positive 3x. Then you multiply your last terms, 1 times 1 is 1. Look to see if you have any like terms to combine. The 9x squared stays out front. 3x plus 3x is 6x. I don't change the exponents of anything because I'm not multiplying right now. And then bring down your plus 1. And our final answer is a trinomial. All right, last slide. I'm going to show you two methods on this one. First, if you notice, we have a binomial times a trinomial. So you can do this kind of like foiling it. Basically, it's going to be a combination of foiling / distributing. What you're going to do is you're going to take your 2x and you're going to multiply it with the x squared, the negative 4x, and the 3. So the 2x has to get multiplied to the entire second polynomial. That's going to give you 2x squared minus 8x squared. Oh, did you guys catch my mistake? Ooh, I caught myself. This first one is 2x cubed. It's a really ugly 3, but hopefully you get that. Because we're multiplying, we're adding exponents. 2x times a negative 4x is negative 8x squared. 2x times 3 is a positive 6x. All right, now you have to take the 5, the second term of this binomial, and that has to get multiplied to everything in the second polynomial also. So 5 times x squared is 5x squared. 5 times negative 4x is negative 4x. No, it's not. Wait, does my eraser work? Yeah. Sometimes this eraser works, sometimes it doesn't, so it's a little picky. Minus 20x. And then 5 times 3 is positive 15. All right, so this first method I'm showing you, you can maybe see the downfall of it is look at how much space it took up horizontally. I'm already into the space of my second problem. But that's okay, we can keep going. Now to get your final answer, you're just combining like terms, starting with the highest exponent. So you got your 2x cubed. Sometimes if I'm combining a lot of terms like this, I might cross them off after I'm done with them, so when I go to see what's left to combine, I don't accidentally use that again. Now look for your x squares. You have a negative 8x squared, positive 5x squared. Combine those and you get a negative 3x squared. I'm done with those. Now look for any x to the first powers. You have a 6x minus 20x. 6 minus 20 is negative 14x. And then look for any constant terms. You just have that plus 15 on the end. So that is one method. That's your distributing / foiling if you're multiplying polynomials bigger than binomials. So the second method I want to show you is called the box method. I actually really like the box method. You could use this instead of foiling if you prefer. But as soon as I get a trinomial with multiplication, I tend to use the box because for me, it just works out better. So how the box method works is you have 2 terms multiplied by 3 terms. So you're going to give yourself a 2 by 3 box. It doesn't matter where you have your 2 term, maybe you had 2 on the left and 3 across the top, that's okay. Now, the 2 terms, the x minus 4, I'm just going to put the x and the minus 4 above those boxes. And then the 3 terms, I'm going to go down the left side. I have a 2x squared, I have a 2x, and I have a negative 5. You want to make sure you keep all your same signs. Now what you're doing is you're going to fill in your boxes with the answers of multiplying the sides of your 2 boxes. So 2x squared times x is 2x cubed. Negative 2x times a negative 4 is negative 8x squared. I think I said 2x, that's 2x squared. All right, 2x times x is 2x squared. 2x times negative 4 is negative 8x. Negative 5 times x is negative 5x. Negative 5 times negative 4 is positive 20. So what I like about this method is I didn't miss any of the multiplication. I didn't accidentally miss a distributing because I set up my box, my 2 by 3 box, because I had 2 terms times 3 terms. I make sure that every single box gets filled in. All right, so now your final answer, the other thing that's nice about this method is your final answer will have your like terms tend to line up easily in this. So start with the 2x cubed, so we just have to write our final answer. Now, do you see how your x squareds are diagonal from each other? So that gives us a negative 8x squared plus 2x squared is a negative 6x squared. And then you have your negative 8x and your negative 5x. That's minus a 13x. Then you've got your 20, so just plus 20 on the end. So that's just another way to multiply polynomials. Nice for organizing if you have something bigger than a binomial.